everyone! Today we are going to be learning about powers and exponents. So today your learning target is I can write and evaluate expressions that involve exponents. Your success criteria to know if you actually are meeting your learning target. You need to be able to write products of repeated factors as powers. And the second one is I can evaluate powers. So this is a two-part lesson. This is part one, and we're going to just kind of go through and show you how to set up some of your things. So first, I want you to make sure that you have a title at the top of your paper, and then also make sure that you have a date. The one in the front stands for Chapter 1. The one afterwards, Section 1. So Chapter 1, Section 1. The title is Powers and Exponents, and then today's date for the first part of the lesson is 9/16/20. All right, I'm going to be writing in different colors. You don't have to use the different colors if you don't want to. I use them to help things stand out a little bit more. If you want to just you can highlight if you want to or whatever. As you get going with your notes, you'll see a little bit how else to do it. Okay, so the first thing that we want to look for is the word power. So the first thing we're going to do is we are going to start looking at some vocabulary words. So we're going to look at power. So the first word is called power. All right, and the power, I'm going to square this up for you. A power is a product of a repeated factor. So this is a product of a repeated factor. And we know from Monday, we know from earlier this week that the word product means to, it's the answer to multiplication, right? So this is answer to multiplication problems. So a power is a product of a repeated factor. And we're going to look at these a little bit more, and we'll get some examples of what this actually means in a second. So next, let's look at the word base. This is where I like to start singing. If you don't want to listen to me sing, you can go ahead and mute this part, but then make sure you turn it back on, okay? So I like to say it's all about the bass, right? So it's all about the bass, okay? We're going to be singing that song because we know that the bass is like the bottom of something, okay? The bass of it's low, right? So like in music, it's low. And Meghan Trainor sings about it's all about the bass, right? So we sit on our base, objects sit on their base. So we're going to talk about the word base. That's our next vocabulary word. And the word base is a power, or the base of a power is a repeated factor. So the base is just the factor that's been repeated over and over and over and over again. So the base is a repeated factor of a power. Okay, we know that the power is the answer to a multiplication problem with repeated factors. All right, next. Our next word that we are going to look at is the word exponent. You may remember this word from elementary school when you had to look at exponents in elementary school. So an exponent I know you looked at base 10, right? So you looked at the tens, and you went to the power of something when you were looking at this, and the exponent was like that little teeny tiny number. So the exponent of a power indicates the number of times that we use the base. So the exponent tells us how many times we use the base number. So how many times that factor is repeated. So how many times we repeat a factor in the base. Okay. Now, let's talk about what this actually looks like and what in the world is Miss Englander even talking about. So when we talk about this, we are looking at how things go together. So we're going to start with our base number. Okay, so we're going to start, let's say, with the number 3. Okay, so the number 3 is going to be my base. We know the base is a repeated factor of a power. So this number right here, in my example, this is my base. And I'm going to write all this in purple for you so that it's written in purple up above so that you can match it. Okay, so base is 3. That's the number that we're going to be working with. Next, we're going to look at the exponent. So exponent was written in blue, but blue might be a little bit hard to see. So I think I'm going to use pink so that it stands out to you. The exponent, let's say 4. Okay, so we're going to use the number 4. So 3 to the 4. So this number here, that is my exponent. Okay, and I'll draw a blue box around it just so that it matches the blue letters up above. All right, next, there's my exponent. We have this whole entire thing. This whole entire thing, 3 with an exponent of 4, this is called the power. Okay, so this whole thing is the power. So we read this as 3 to the power of 4. So when we read this, these two numbers go together and they are known as the power. I got the power, right? So when we've got the power, we've like souped up, right? We've gotten really big. So this guy, he was just a 3 by himself, but now he's got a superpower of 4. So this is the power. All right, the whole thing is a power. Now let's look at the rest of this. So in this, we have the number 3, and it's being used as a factor. And we know that factors are numbers that are multiplied together to get the product, which is the answer. So we're going to look at this, and we're going to say 3 times, yeah, welcome to middle school. We just switched the multiplication sign on you. Yep, we just did that. So multiplication sign is now a little tiny dot in between the numbers. If you didn't know that, I'm sorry. We're moving away from the x because the x is going to be used as, well, an x pretty soon when we get to algebra. Okay, so 3 times 3 times 3 times 3. That's what that means. Okay, so when we have 3 to the power of 4, that just means that we have multiplied 3 by itself 4 times. But mathematicians are really lazy. That's right, they are. They're really lazy. So they only like to do things in small chunks. So instead of writing 3 times 3 times 3 times 3, we wrote 3 to the 4, so we don't have to write all those multiplication signs. Because if we had like 3 to the 10, we would be writing 3s forever. Okay, so that's why we do it that way. All right, so 3 times 3 times 3 times 3. All right, so now we're going to drop down and we're going to talk about what does it mean when we write expressions as powers. So we're going to go ahead and we're going to write example 1 in our book here. And the question that we need to be able to answer in example 1 is our first question. How do you write expressions as powers? Okay, so that's our question. How do we write expressions as powers? Oh, see, I told you I was going to forget letters. Okay, so how do we do that? How in the world do we write expressions as powers? Well, expressions first, if you remember from elementary school, expressions are just math phrases. Okay, they don't have an equal sign. Equations have an equal sign. So how do we write expressions as powers? Well, the way that we write them, I'm going to let you summarize and answer that question at the end based on what you see. Okay, so let's start with this first one. Example A. I have 7 times 7 times 7 times 7 times 7. So if I wanted to write this expression as a power, we know a power is just a factor that's been souped up, right? It's just got an extra little number up top. I would count up how many numbers I have, and then I would just write a power. So my base, it's all about the base, about the base. This one, it's all about the 7, about the 7, about the 7, right? My base number is the 7. So in order to do this, in order to solve this, I would write 7 to the power of, it's all about the 7, about the 7, about the 7, about the 7, about the 7. That goes 5 times. So I have 5 7s here. So my power is 7 to the power of 5. That's a power. I took this expression and I turned it into a power. That's it. That's all you do. All right, let's do another one. Let's do example B. This time we are going to have 12. So I have 12 times 12 times 12. It's all about the, 12. Good. Okay, so it's all about the 12 now. So our base number is the 12. And how many times did I have to sing about the 12, about this base? Yep, 3. Good. All right, so 3. So 1 12, 2 12s, 3 12s. That's how I got this power. Another way we can say this is cubed. 12 cubed. 3 is a cube. So this is 12 cubed. Or 12 to the 3rd power. Either way is fine. All right, it is your turn. I want you to do a try it. Okay, so now it's your turn. You are going to do a try it. We're going to do 2 of them. So try it number, if you were looking in your math textbook online, this is try it number 1. And I want you to do try it number 2. All right, so try it number 1 says 2 times 2, and they use these multiplication signs, the X, even though I told you we weren't going to use the X. I'm still putting it in there just so you can see it, because that's how they did it in the book. Make this into a power. If you need to pause the video to do this, please do, so that way you don't get the answer. And number 2, 6 All right, your turn. You solve both of these, and then we're going to check our work. So pause the video, answer these 2 questions, and then when you're ready, go ahead and hit play because I'm going to solve these right now. So 2 times 2 times 2 is 2 to the power of 3. So 1, 2, 3, 2s to the 3s. And 6. Let's check out this guy. 1, 2, 3, 4, 5, 6. Ooh, I have 6 to the power of 6. How did you do? How did you do on this one? Okay, go ahead and answer this question down below. How do we write expressions as powers? Write that down below underneath your try-its. And then turn your page when you're ready. Hit pause if you need to. And we're going to go on to part 2. Also out to the side, I want you to tell me, how are you doing so far with your understanding? 3, I'm doing awesome. I can totally write products of repeated factors as powers. 2, I'm getting there. I still need some practice. 1, I have no clue what Miss Englander did, so I'm going to go back. I'm going to rewatch this video, and I'm going to do some more practice. And then I'm going to ask questions tomorrow so that I can get some help. When you're ready, turn the page. All right. Our next question that we need to be able to answer, is example 2. And how do you find the value of powers? So example 2. Example 2 says, how do you find the value of each power? How do you find the value of each power? All right, let's talk about this one now. Example 2. All right, we're going to start with an example with a power that looks like this. So my first power says 7 squared, or 7 to the power of 2. The way that we're going to solve this one is we are going to say, 1, how many 7s do I have? Well, 7 to the 2 means it's all about the 7, I only have, you're right, 2 7s. So really when I do this, this means 7 times 7. What is 7 times 7? Well, we know 7 times 7 is 49. So we're going to write 7 to the power of 2, or 7 squared, which is what they gave us. That's that. That's the power. We want to know the value. Well, the value is these 2 factors multiplied together in order to get the product. So the value is how much it's worth. It's worth 49. So we're going to use these 2 factors to get a value of 49. Okay, next, let's look at another one. The next one is 5 to the power of 3. So let's think about this. We have 5 to the power of 3. So let's talk about the base. Which one's the base number? It's all about the 5. Yep. Okay, and how many times is this 5 being repeated? 3. Yeah, totally. So we're going to have 5 times 5 times 5. All those factors have to get multiplied together in order to solve or get the power value. We want the value of this guy, so we have to multiply those. Okay, so what is 5 times 5? Right, 25. So when we multiply this, we know 5 times 5 is 25. And 25 times this 5 right here gives us a value of 125. So our value of 5 to the power of 3, or 5 cubed, is 125. Nice work. All right. Let's go ahead and talk about some try-its. Let's talk about some try-its and see where you're at with this. Our first try-it that I want you to accomplish is try-it number 5 if you were in your workbook, or on Big Ideas on the ebook. It's try-it number 5. And try-it number 5 says 6 to the power of 3. And then the next one I want you to do is try-it number 7, which says 3 to the power of 4. So we're going to find the value of both of those numbers. Go ahead and hit pause right now so that you can work on both of those. And so that way you don't get the answer until you're ready, because I'm going to solve them right now. All right, so the first one that we are looking at, try-it number 5, means 6 times 6 times 6. So this means 6 times 6, 36, times another 6, which gives us a grand total of 216. So my power total here is 216. That's my value. All right, the next one. This one is asking me to multiply this 3 4 different times, right? The base is 3, power of 4, so I am going 3 times 3 times 3 times 3. Do you see what I mean about mathematicians wanting to be lazy, right? That could go on forever. Okay, here we go. 3 times 3 is 9. And I know that 3 times 3 over here is 9, right? And 9 times 9 is 81. So the value of this one is 81. If you showed your work a little bit different, that's okay. Remember, there's more than one way to do math. I just like to organize my work like that. Okay, your job right now is to answer the question for example 2. How do you find the value of each power? How did we find the value of this? What did we have to do? Summarize that for me down below. So put your answer here. Answer your essential question there. And then off to the side, I want you to tell me 3, I'm doing awesome. I totally understand how to find the value of each power. I could explain this to you. 2, I still need some extra practice with this. 1, I have no clue what missing letter did. I'm going to go back, rewatch the video, and get some extra help. All right, when you are done with this part and telling me where you are at with your level of understanding, you may head on over to the next part of your work for today.